We continue the same project, and now we have a board and also we have a sand core. And I have created here because I want to have more stability when we put sand core in mold, and it's in both sides. I go with the extrude cut. You can see also we can check in sketch. I go with the extrude cut and also some fillet. And because we want to have it two part in one casting, and I have created with a pattern, and you can see also with the pattern. And when you go with the pattern, only you need to say direction here, in which direction, and yeah, how, and dimension also, and how many pieces you want to have it. But we want two part. I want to go and explain how we create it. And now we have a sand core. It's here, and also sand core here. But it's important thing it's in a runner system, and also in gauge here, because in gauge I have created like that. And when we want to put sand in mold, it's easy. We can put here sand, and also we have here more for orientation. Don't rotate sand core when we put inside. And also when it's here, when it's casting, when aluminum is floating, you can see it's not go direct. I want to have it like that, and we can see it's not go direct aluminum in a core, and but we have in angle and floating better aluminum, because if it's go direct we can destroy sand core. Like we said in previous lecture, we said because we want to have it straight, and I made it like that. And it's also this type, it's good for floating. If we have a problem with the floating, we can have it filter here, because we said here, but now we can create it here, because also when we make a simulation you can see when it's floating it's going up with a turbulence, and it's a good technique also if you use like that. When you put sand in the mold, be careful, because every time when you put inside, sometimes it's you have some sand go down, and when you cast it you have a sand inside in aluminum. But every time you need to blow with the air and push out the sand before you start casting. Every casting it's better if you blow with the air, if you have a sand core inside. And also when we create the mold, be careful, we need to have here, we need to have a line here to go gas out, because if it's standing gas it's not going out, also it's stuck here gas, and it can be some you can see like a bubble when it's going aluminum, and it's better to go out. Every time when you're casting aluminum with the sand core, first you need to think for gas, in which way need to go out. If it's closed you can only open a hold all and gas go out. And we can create like that, and we can make with a color. Because we have sand like that, and we can create also in that in another core. We go edit, and we can change edit, and we can go insane. and we have a runner system. And this line is because we have created because we want to know when we cut it. And also for cutting we know here, or we can mark it for cutting which area we need to cut, because we said in this area it's for maximum, and we know we can cut it here. But first we need to take it away some, and after that we can cut. For cutting it's better if you mark it here and also mark it here, and operator they know when they cut in which area it's they need to cut, and we can create it also for cut. We can go in two different way. One is for with a revolve cut, and also one which we can go with a wrap command, but this time I go with a revolve cut. I want to show only in one, and it's the same for all. This and this and this should be parallel. Not here, because if we go in here and this, here it's maximum, but we need to move the sketch. And we'll leave, we want to have a space here for 3. I want to see if I can have it this and this parallel, and now we can create 0.5 millimeter. And we can create it here with a revolve cut. And also we have a draft here, and we can cut. This is one way, and also it's another way, it's with a wrap command, but also this is a easy command, and we know in which area we want to cut. But it's not good if we leave too much, because if you leave too much it's not floating well. It's only for market. Like we said 0.5, it's okay, or 0.2. Only for market, we know in which place we want to cut, and we have it also market for cut. And we have space for machine at this area, and also thread. Now it looks like it's complete, and we continue to create for casting and make simulation, and we can see for floating also. Now we continue to make a simulation, but first we need to define a material, and we can go in material, and also we have a 43100, and we can have a temperature also. When we have a temperature 760 Celsius, restore, and we can say OK, and we need to gravity, in which direction we need to change direction, and in this it's 90 degree. And also we have here we have a point for start filling with aluminum. Now we have a sand core, but we need to create a sand core, and we have it core here, and we have it, we can this and this, we can say sand core, but it depends which type of sand you use, but we use this type. And temperature in sand it's better every time when you want to cast it. It's better to put in close to heat a little, and when you heat it, it's better for casting, and it's not a different temperature, but we can say for above the 40 degree Celsius, and I think it's okay in that temperature. Or sometimes it's better if you can heat it more, it's much better for cast it, but not too much. And we can continue for next. We can go for mold, and when we go mold, we have material for mold, and also temperature in mold, it's 280 degree. We need to go again in mold because we need to create here, it's a top, and now we have a speed. We can change the speed parameter. We can say 0.5, 0.6, it's okay. We continue, and when we finish that, we can go for run, and we can have a size for, we can change also size, and we can have a 3 mesh, 3mm not. And we can start run both, and we can see result in both for analysis. After some hour, now we have an analysis, and we can control, and we can see for floating first, and not floating, it's not floating here, but we have floating here because we have a filling. And we see because it's pressure go first here. But floating it's good, and also it can be some here some air, but we cut, it's not problem, but every time it's better if you move the face a little, because when it can be some air here, but it looks good. If we see again, and also we can see when it start to feel a bit here, not go direct in core, and we have created, it's good for floating like that. And if we have a problem, some pore or something, we can only open a little, but here I don't think so we have a problem. And also we can go in last air control, and last air it's only in surface here in that, but it's no problem for casting here. And also we cut it, also here we cut it because we cut and we machine it. And we go and control for shrinkage. We can control shrinkage. Start. If we have some problem here, but I don't think so, because you can see it's go out, shrink it, and we don't have a problem also shrink it. And also we can control for pore. We have some inside, some small pore here, because we can micro pore control. Pipe shrinkage, we understand it's in top, but it looks, everything is correct. And if we want to have it more balanced for floating, we can have it here in this area, create stop a little the material and go floating. make a little smaller from back, not from front, because front it's a sand core, and here, but I don't think so it's a problem, like we said. It's not a big difference between, and it looks good. And here we know because we have some cold shots here. Because when it's floating aluminum, it's going in both sides and floating all, and here it's standing, not floating with a, yeah, it's like it's standing. But also when we want to have it better, we can increase a little radius, and when we increase a little radius, it's floating better if we have a problem. But I don't think so it's a problem, but when we machine it we can control and see. But if we have a problem, we can increase the radius here.